This is a very common trap in school physics. Most students will say that if the temperature goes up, then the reading on the voltmeter must go down. But they're wrong. I'm going to show you 3 ways to use the infamous turd rule correctly so that you won't lose those marks again. Method 1. Ohm's law. If we increase the temperature of the surroundings, what happens to the thermistor? Reach for the turd. Temperature goes up, so resistance goes down. This in turn means that the total resistance of the circuit decreases. So from Ohm's law, this means that the current in the circuit increases. Current through a fixed resistor increases, then from Ohm's law, again, the voltage across it must go up. If you felt like that was a lot of maths, wait till you see how simple this becomes if you think of it in terms of a playground fight. Method 2. Resistors in a series circuit. The voltage is split depending on which resistor has the biggest value or is stronger. The thermistor's resistance has plummeted. This means it's not as strong as the fixed resistor, and therefore the fixed resistor bullies it and takes a bigger share of the voltage. The poor old thermistor ends up with a smaller slice of the voltage pie. And this is exactly how in the real world we can use a change of temperature to trigger an action. The increased voltage across the fixed resistor can be used to switch on, say, the fan inside your computer or turn off the heating elements in your toaster. The trap is thinking that because the resistance of the thermistor decreases, the voltage on the voltmeter has to decrease too. But this is wrong. It depends entirely on whereabouts in the circuit the voltmeter is actually looking. Method 3. Algebra. Now, for the maths purists out there, here is a third and final way to prove it using the potential divider formula. As the total resistance on the bottom of the formula goes down, everything else is fixed, means that Vout must rise. Although it's obvious, your first question should always be, where is the voltmeter? It's the first step in getting all the marks in these questions. The beauty of electronic circuits is that there's always several ways to solve the question. What's really going on here is that we've used 3 different methods to do exactly the same thing. Current flow, resistor ratios, and the potential divider. Which method do you prefer? I've been doing these things so long that I just use them interchangeably depending what kind of mood I'm in. It's great if you can get there. If not, pick the one that suits you best.